Lesson 9.2, Populations, Samples, and Hypotheses. So a population is the collection of all the data of interest. For example, it's all the people. That's often pretty hard to do, though. So we do a sample. A sample is a subset or a smaller group of the population. For example, only the people surveyed. In this experiment, the owner of a dance studio surveys 32 dancers and finds that 25 of them prefer hip-hop. What's the population and what's the sample? Well, our population would be all of interest. So that would be all dancers at the studio. The sample is the 32 who were surveyed. Part B. A counselor at middle school reviews 225 student class schedules and finds that 46 have a science class during the first period. So what is the population? Remember, population's everything. So all students at the school. And what's our sample? That's right, the 225 students who were reviewed. Why don't you pause this and try number 5. And when you're done, the population is adults over 18 in USA, and your sample is going to be the 1,152 adults who were surveyed. So the population is everybody, the sample is just a smaller group. A parameter is a number describing a population characteristic. So a parameter describes the whole population. A statistic describes the sample. Oh, hey, they go together. Parameter and population. Population parameter, they both start with P's. And statistic and sample go together. Sample and statistic, they both start with S's. Way to remember that. For all teenagers who had jobs last summer in a certain town, the mean hourly wage was $8.25. Is the mean hourly wage a parameter or a statistic? Well, we have to decide. Is this the entire population or just a sample? And it says for all the teenagers. So that indicates it is a parameter. How about this one? In a survey of 912 men in Central America, found the standard deviation for the lengths of their feet is about 4 centimeters. Is the standard deviation a parameter or a statistic? Well, is this all the men? No, this is just 912 of them. So that is a sample, which means the standard deviation would be a statistic. Why don't you try number 9? Pause it while you do it. When you're done, your answer should be a statistic. Stat. So why would we worry about samples and statistics instead of just doing the whole population? Well, because the whole population may be very large. All right, we also have something called a proportion, which is the ratio of the members with that characteristic to the total number of members. So if 10 out of 20 people are redheads in this particular sample, it would be 10 to 20, or 1/2. All right, so the book is going to ask you to use technology to simulate flipping a coin 20 times. What proportion of the 20 flips results in heads? And the book suggests you use a random integer generator. So you use the function randint, and you put the lowest number and the highest number. So for flipping a coin, it's either a 1 or a 2, heads or tails. And you'd have to do it 20 times to keep track. Well, that could take a while. So we could use random.org for coins, and they also have one for dice. So let's try the one for coins. All right, and we're going to flip it 20 times. Select a coin type. Oh, what kind of cool coin shall we do? Let's do USA, and let's do a George Washington dollar. We're going to flip the coins. And there we go. And we wanted to know how many heads. So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 heads. All right, so we had 11 heads out of the 20. So our proportion was 11 out of 20, which is about 55%. Why don't you try number 17? A hypothesis is a claim about a population characteristic. And so to analyze, you need to distinguish between the results that occur by chance and those that are unlikely to occur by chance. So for example, you roll a 6-sided dice 5 times and do not get an even number. The probability of this happening is 1/2 to the 5th, because half the numbers are even, so are odd in this case, I guess. So it'd be half for the first roll times half for the second roll times half for the third roll. So this is independent events. So it's half times itself 5 times. Should be about a 3%. You suspect that the die favors odd numbers. The die maker claims that it doesn't. What should you conclude when you roll the actual die 50 times and get 23 odd numbers? All right. So for part A, we have 23 over 50, which is 0.46. Now, the die maker claims that should be 1/2. Is 0.46 close to 0.5? Yes. So the claim is likely true. Part B. He rolled the die 50 times and got 40 odd numbers. So it is 40 out of 50, which is 0.8. That's a long way from a half. So since it's a long way for the half, the claim is likely false. Why don't you try number 21? Pause it while you solve it. When you're done, part A is true, part B is false.